Alright, welcome back. So in this video, we are just going to go over an example using the washer method. So you can see here, I've already set up the image we're going to use and a little graphic that I'm going to refer to, but let me write out what the example is first so that you have it written formally out. So what we are going to do is find the volume of the solid of revolution, and we're taking the region that is shown here, which is the region between y equals x cubed and x equals 2. And we're doing this around the y-axis. So the idea here is that we are taking these little washers, and so they have a width that has, sorry, let me draw the rectangle that I'm trying to indicate here. So we have this little rectangle that's going to sort of sweep out our washer, and we're going to be adding those washer volumes up together. So on our washer picture I've drawn here, you can imagine this little rectangle. It starts in one location, and then it's going to sweep out this little volume of the disc. So it starts here as R, and then it's going to kind of sweep around until it gets out here to the other side. And it's making this washer as it does that, as it sort of rotates around. And so in this shape, we're going to need the outside radius and the inside radius. So let's look at those first. Here we're going to have the outside radius squared, and then we'll subtract off the inside radius squared. That's just using our formula. Or you can remember that we're finding the full disk volume and then subtracting off the little disk volume. Then each of these disks has a height or a width you could think of dy. So that's my dy here with my radius of that washer. It's not really even a radius, right? It's like the bigger radius minus the smaller radius. And so my outside function is this x equals 2. And then the inside function is the y equals x cubed. So we're sort of starting from the outside, that's the edge, and then we subtract off the inside edge. So just remember our formula. We take pi times the outside radius squared minus the inside radius squared, and then dy. So we're going to need some more information here. I just want to point out that we're going to need this point where they intersect, since our y's are going from 0 up to that point. And so if you look here, you could type in 2 for x. 2 cubed is 8. So that y value is just 8 where they intersect. And so my y values are going to be going from 0 to 8. 0 to 8. And then we're going to have pi times, we're going to do the outside radius squared. So the outside is 2 squared. And then I subtract off the inside radius squared. But we just need to be a little careful because the inside is y equals x cubed, but we need it as x equals something. So what we can do is take the cube root of y, and we get that. So we just take the cube root of both sides to get x equals the cube root of y, and so that's what's going to go in this spot here. And then we have dy. So I've just kind of blundered through finding all these parts, so let's take a second and make sure we understand what's going on. So I'm taking this shape and I'm sort of sweeping it around, and I've actually drawn out the volumes here. So we've taken this little shape, I've sort of laid it flat down, we're revolving it around, so it's going around. And then it's making this shape that sort of has like this outside cylinder and then this inside cup carved out. So you can imagine that the outside cylinder is sort of going around. It's going around, we're getting this outside shape, and then we're carving out the inside part that's going to be taken out of the shape. And so we use washers because of that hole in the middle, that part that isn't being included. Okay, So we have our integral, it goes from 0 to 8, and then we're doing the outside radius minus the inside radius with the squares on there. So we're taking the full area and then subtracting off that hollow part in the middle. All that's left now is just to solve this integral. It's not super pretty, so if you're not all that interested in doing it, you could maybe just skip to the end and see the solution, but I'm going to work through it just in case it is helpful to you to see how it works. Okay, so we're doing the integral from 0 to 8 of pi, and I'm going to work on simplifying this inside bit so that it's easier for me to integrate. So 2 squared is 4, and then I'm going to write y, the cube root of y, as y to the 1/3, and that's getting squared. So this is going to help me out when I'm trying to integrate. We can then simplify it with that squared. So I'm going to think of this pi separately now. Well, actually, let's just leave it in there. What the heck? And so now I have 4 minus, when I do 1/3, the y to the 1/3 squared, I multiply the exponents, so I'm just getting y to the 2/3. That's if you have like x squared cubed, you'd get x to the 6th because you multiply those exponents. So the same thing's happening here. I have 1/3 times 2 to get my 2/3. Okay, now I can integrate. So I'm getting pi times, I have 4y minus, I'm going to add 1 to the exponent, so it becomes 5/3, and then I divide by that new exponent. And we're doing this from 0 to 8. You can see here I basically just factored that pi out, so I guess I did end up doing that. It just sort of hangs around because it's a constant that goes with the integral. So again, we added the 1, the 3/3, to the 2/3 to get the 5/3, and now we just need to simplify this by substituting in the values. So something that might be helpful just as an intermediate step is to simplify this a little bit. So that fraction 1/5/3, we can multiply by the reciprocal for 3/5. And then I am going to just replace this as the cube root of y to the 5th. So I'm converting it back into a radical, just to help me out with the math. Okay, so we plug in 8 first. So 4 times 8 minus 3/5 times the cube root of 8 to the 5th. And then I subtract off what happens when I plug in 0. But that one's just going to disappear, which is nice. That keeps happening to us with the way these problems have been set up. Okay, and so now I just need to simplify this whole first part. So I have pi times 32 minus 3/5 times, and I did this part on a calculator ahead of time. We're doing the cube root of 32,768. This just happens to be a nice number, which is great. I like that. So we're doing 32 minus 3/5, and then the cube root of 32,768 is just 32. So you can use a calculator for this. This is what I did. And now we are just simplifying. So a little trick here to help you simplify this if you're trying to do it by hand. I like to think of this 32 that's in front. This is like 1/32, and then we're subtracting off 3/5 of a 32. So you can think of us as having 5/5 of a 32, and then minus 3/5 of that 32. And so I'm left with 2/5 times 32. And there we go. So I guess we could go one more step. This is 64/5 pi, which if you type into your calculator, we're going to get 40.2 for that volume. So this is the solution for our volume of that solid of revolution that we found. And there we go, that's it. So the process isn't too much different from disk method. We just set up the integral and then solve. That's it for this video. Thanks so much for watching. I'll talk to you in the next one.